Hi scholars, in this module our two main topics are measurement and replication. The objectives in this video lecture are to define behaviors, dimensions, and recording procedures, to calculate IOA, inter-observer agreement, using the point-by-point agreement method, to revisit replication, and to demonstrate writing research questions for systematic replication. Let's start with strong examples of observable, measurable behavior. These are examples of behavior that we can count, see, hear, or repeat. Example 1. Initiate a task analysis step within 5 seconds and complete it within 15 seconds. Example 2. Write a 6-word sentence with correct grammar and spelling. Example 3. Participant who will be standing 6 feet from the item will locate the item and select it by grasping, touching, or pointing to the item within 30 seconds of the task direction. Example 4. Write your example here. Let's analyze the dimensions of behavior using the 6 categories: count, rate, duration, latency, trials to criterion, and magnitude. Count or frequency refers to how many times a behavior occurs. Note that this should be a behavior that has a clear onset and offset. For example, number of words written, number of steps taken independently. If the opportunities are constant across observations, then we can simply report a number. If the opportunities change across observations, then we would report our count or frequency as a percentage. Rate refers to frequency per unit of time. For example, number of words read correct per minute. Duration is the length of time it takes to complete a response, or the total amount of time that a response occurs. For example, length of time spent putting a puzzle together. Latency is how long from some specified cue it takes for a response to occur. For example, the length of time to respond to a WH question. Trials to criterion is a measure of the number of responses or practice opportunities needed for a person to achieve a pre-established level of accuracy or proficiency. It's derived from count, frequency, latency, or duration. It's used to assess skill acquisition, or often in single case research, it's used to evaluate the efficiency of an intervention. Magnitude is the intensity or strength of a response. For example, the speed of a pitch, how far one kicks a ball, volume when speaking, or a rating on a self-injury trauma scale. Example 1 was initiate a task analysis step within 5 seconds and complete it within 15 seconds. This behavior has 2 dimensions. One is latency for initiating, and the other is duration for time it takes to complete the step. Example 2 was write a 6-word sentence with correct grammar and spelling. This is narrowly a count behavior. For example, we could count, yes, they wrote a 6-word syntactically correct sentence with no spelling errors once, twice, 3 times. However, we can evaluate the dimension of magnitude if we use a valid writing rubric that would allow us to evaluate the degree to which the student used grammar and spelling in writing that 6-word sentence. Example 3 was participant who will be standing 6 feet from the item will locate the item and select it by grasping, touching, or pointing to the item within 30 seconds of the task direction. Some behaviors leave byproducts that can be examined later, and permanent product recording allows you to do just that. For example, you might be interested in the number of vocational tasks a person completes, the number of worksheet problems completed correctly, the cleanliness of a room once a student leaves, the appropriateness of the student's dress or appearance, or the number of appropriate objects a particular student has used. The disadvantage of this approach is that it can only be used with those behaviors that produce a tangible byproduct, and it provides you with little information about the process by which the byproduct was produced. When behaviors do not produce a tangible byproduct, we can use direct observation in several ways. For example, event recording, interval recording, time sampling, latency recording, and duration recording. Event recording is used to capture the behavioral dimensions of frequency and rate. You simply tally or count the number of times the targeted behavior occurs. It's probably the most commonly used recording system because it's fairly easy to use, straightforward to interpret, produces data that can be easily graphed, and is relevant to many behaviors that educators and clinicians are interested in. On the next few slides, I'll show you some data sheets that allow you to use event recording. Here is an event recording sheet for Emily Raptor, who is working at a department store as part of her job training. The job coach is tallying the number of times that Emily greets customers, asks for assistance, provides assistance, and folds clothing. Each is counted by time block so the job coach can see how Emily paces herself throughout her shift. Event recording has some disadvantages and some advantages. The primary benefits are that it's easy to use and generally fairly accurate. It's also useful across many topographies of discrete behaviors. The drawback is that you have to watch continuously or you'll miss a behavior. It also can't be used with continuous behaviors that last a sustained amount of time. Finally, when a behavior happens with a very high frequency, one's accuracy in using event recording decreases substantially. Sometimes it is sufficient to approximate the actual number of times that a behavior occurs. Interval recording and time sampling make estimates of the occurrence of a behavior by dividing an observation session into discrete intervals and then recording whether a response occurs throughout an interval, whole interval, during any point during that interval, partial interval, or during a fixed time period at the end of an interval, momentary time sampling. Such approaches allow you to record continuous and high-frequency behaviors. I'll talk about each of these separately. The advantages of whole interval recording are that it can be used to make estimates of behavior that occur continuously. It can also be converted to a percentage, 10% of intervals, 25% of intervals, 100% of intervals, etc., which are very interpretable. The challenges are that it tends to underestimate the overall occurrence of responding, especially when behaviors last a relatively short amount of time in relation to the interval length. If you think about it, behaviors that last just 1 second shorter than the entire interval won't be counted. In addition, the whole interval recording requires you to watch the student constantly, which requires time and undivided attention, as well as can promote observer fatigue. The advantages of partial interval recording are that it can provide an estimate of behaviors that occur for a short period of time, as well as for high-frequency behaviors. Contrary to whole interval recording, partial interval recording tends to overestimate the occurrence of behavior. So if your interval lasts 30 seconds, a brief 1 second occurrence of the behavior would cause you to count the entire interval. The larger the interval, the greater the overestimation. Like whole interval recording, it requires constant observation. The advantages of momentary time sampling is that it's very efficient because you do not have to watch people constantly. It also enables you to collect data on multiple students simultaneously. The drawback is that it can underestimate behavior that occurs only briefly. As you can see on this chart, the recording system that you use can lead to quite different conclusions. Therefore, it is essential that you carefully think about which approach best reflects the behaviors and dimensions of interest. Duration recording is used when you want to measure how long a behavior lasts. Obviously, as the name suggests, duration recording is used to measure the dimension of duration. It is most appropriate for behaviors that occur infrequently but last for some length of time. Next, there's latency recording, which is used to measure the dimension of latency. The advantages follow as would be expected. It provides an index of temporal relation between the antecedent stimulus and responding, and can easily be converted to an average latency. The disadvantages are that it requires use of a timing device, and that the base rate of the antecedent event defines the amount of data that can be collected. For example, if a teacher makes only one request, you only get one data point for that session. Which recording system would you use for collecting baseline data to record the frequency with which a child throws an object during whole group instruction? Which recording system would you use to track out-of-seat behavior when it's perceived as problematic and long-lasting? Which recording system would you use for behavior making complaining remarks? As single subject researchers, we strive to ensure the consistency in our ratings. One way that we do this is by evaluating our consistency in recording the target behavior. We can use inner observer agreement. In single case research, we calculate inner observer agreement for a case and report the mean and range for each case. In the example on the screen, we have 2 observers and 12 sets of observation data. In this data, we have 7 agreements and 5 disagreements. Using the point-by-point agreement method, we can calculate an inner observer agreement of 58%. In this case, we would want to revisit the behavior, make sure it's operationally defined, and retrain our observers because we'd want to strive for an inner observer agreement rate of 80% or greater. In this segment of the lecture, we'll revisit and add to what we know about replication. In single subject experimental design, the 3 main reasons that we replicate include assessing the reliability of findings, assessing the generality of findings, and looking for exceptions. Let's gain some practice with identifying intra-subject and inter-subject replication. In an AB-AB design, we need 3 demonstrations of effect for a functional relation, and these demonstrations are circled in red. We see one effect between A to B, one effect between B back to A, and the effect is replicated again from A to B. So we have 3 demonstrations. In other words, for this one participant's data, we see intra-subject replication. This design is a multiple probe across behaviors. We see one participant's data across 3 sets of behavior. The replications of effect are circled in red. Is this intra-subject or inter-subject replication? Well, there's only one participant, so this is intra-subject replication. This graph shows a multiple baseline across participants. There are 3 demonstrations of effect, and the 2 replications are circled in red. Is this intra-subject replication or inter-subject replication? When we conduct single case research, our research questions relate to the relationship between the introduction of an intervention or treatment and change in the dependent variable. Usually, research questions name the independent variable, dependent variable, and the expected pattern of change. The question, will a pictorial graphic organizer increase the percentage of information students can recall, is written to name the independent variable, pictorial graphic organizer, the dependent variable, percentage of information recalled, and the expected pattern, increase. The researchers really want to know more than this. Specifically, they want to know whether they'll achieve 3 demonstrations of effect at 3 points in time. So they could phrase the question as, is there a functional relation between the use of pictorial graphic organizer and increased level of scores on information recall assessments? If you were going to implement a direct replication of the study, with the question, will students with ID locate grocery items more efficiently with audio or picture lists? How would you rewrite the question using, is there a functional relation in the frame on the screen? If you were going to implement a systematic replication of the study with the question, will students with ID locate grocery items more efficiently with audio or picture lists? This means that you would change one or more variable. For example, maybe you'd change the setting. Instead of locating items in a grocery store, you could have students locate items in the context of preparing breakfast in the kitchen at school. Reflect on what you know now in relation to the objectives of this lecture. Define behaviors, dimensions, recording procedures, calculate reliability using the point-by-point agreement method, answer the questions why and how for replication, and demonstrate writing research questions for systematic replication.